Hello everyone. Now we will continue our learning on reservoir properties or rock properties in relation to reservoir simulation. And now the specific topic is about heterogeneity, rock heterogeneity or reservoir heterogeneity. Okay, so heterogeneity means very simple. The reservoir is heterogeneous. So the properties are different from one zone to another zone, okay? From one zone to other zones, both vertically and or laterally, okay? Vertically, for example, based on this picture, okay? You see the vertical properties are different, vertical properties. You can just see the color. The colors are different. It shows that the properties are different. Maybe the porosity, maybe the permeability, maybe the saturation, all right? And not only vertically, but also laterally here, okay? The properties are different. So if you just move from this well to this well, you will see different reservoir maybe, or different zone, okay? Maybe the permeability drops from high permeability to low permeability, or from high porosity to low porosity, something like that. It can also be from high pressure to low pressure, or from high water cut to water cut. It can also be that. So heterogeneity can be in terms of static properties like permeability, porosity, and it can also be heterogeneous based on dynamic properties like water cut, pressure, and so on and so forth. But what we want to focus on in this class, it's about static properties. So the permeability can be different, the porosity can be different, okay? The rock properties are different vertically and or laterally. Yeah, heterogeneity from conceptual point of view. Heterogeneity can happen or can occur in many scales, right? It's a multi-scale phenomena. We start with gigascale, okay, more than 1,000 feet. Heterogeneity can occur due to, you can see ceiling fault, yeah, ceiling fault. Here we have fault, and if I am, for example, here, if I just move to the east or to the right, I will meet this chocolate or dark brown zone, or maybe it is sandstone, the orange zone, and the brown is shale. So if we just move, for example, here, from here, you move to the right and you will see a reservoir that are very different from this zone. Yeah, because if you go to the east or to the right, you will see shale. Okay, so that is one of examples of heterogeneity. So if you just move a little bit, maybe if you move from one location to maybe 100 meters from that location, you will see a very different reservoir properties. In this case, from sandstone reservoir, you will find shale just by moving a little bit. Okay, but the fault can also be semi-sealing or non-sealing, and giga scale heterogeneity can also occur due to fracturing. Maybe you have naturally fractured reservoir. The fracture can be tight or can be open, but whatever the fracturing is, it will be the source of heterogeneity. So if you are here, maybe you have relatively low permeability, but you just move to the east, to the right, kita pergi ke kanan, and you will find a zone with a very high permeability. And actually, that zone is the fracture. So if you just move to the north, move to the west, to the east, or to the south, ya, ke utara, barat, selatan, ke timur, the properties are changing. Low permeability to high permeability, low permeability again, high permeability again. Why? Because you see many fractures. Yeah, and the properties of the fracture are very different from the matrix. Yeah, the rock matrix and the fractures, they have different porosity, they have different permeability. And now mega scale from 100 feet to 1,000 feet can be due to boundaries, genetic units. Yeah, you just have two reservoirs or many reservoirs with different unit, different boundaries. So they are just different reservoir. Like here, this reservoir, and this is another reservoir. So if you just move from this reservoir to that reservoir, you will find another reservoir that is very, very different in properties. So if I drill my well here, all right, and then I perforate my well here, and then I just move deeper here, I will see the very, very different phenomena, different performance of the fluid from the upper reservoir to the lower reservoir. The properties, the performance can be different. Why? Because heterogeneity. And this is permeability zonation within genetic units. They are the same, they are within the same reservoir, but they have different properties. So one reservoir with three zones, and maybe zone with high permeability, zone with, yeah, relatively good permeability, but not as big as the lower, and the upper maybe zone with the lowest, the smallest permeability. It can happen because of heterogeneity, because of sedimentation, because of tectonics. It can happen. Macro, from inch to feet. Baffles within genetic units, this is very, very important. Just baffle, all right? They are not continue. They are not continuous. They are like this, just baffle, sekat, sekat yang menghalangi aliran. Ya. This baffle will hinder the flow. So the flow can be quite complex, maybe from here, there, and there, because of these baffles. Yeah, it can happen. And macro heterogeneity can also due to lamination, cross bedding, something like this, due to, yeah, lamination due to the sedimentation process, and then you have faults there. It will cause heterogeneity. And of course, heterogeneity can also occur in micro scale. For example, due to difference of textural types, difference in mineralogy, and other aspects. Okay, so they have very, very different properties. Between this zonation and then this zone, they really have different property. So heterogeneity can occur in all scales. Yeah, in giga scale, in mega scale, in macro scale, and of course in also in micro scale.